All electrons have the same charge. Every single one. Everywhere in the universe. For all time. That's a law of nature. Now consider this. All the coins in my pocket are silver. Also universally true. At least as far as my pocket is concerned. But these feel completely different. One is a deep feature of reality. The other is a coincidence. So what is a law of nature? What separates necessity from accident? This turns out to be one of the hardest questions in philosophy of science. The oldest answer comes from David Hume, developed later by John Stuart Mill, Frank Ramsey, and David Lewis. On this view, laws are nothing more than universal regularities, true generalizations that hold across all space and time. The appeal is elegant simplicity. No mysterious extra ingredients. Laws are just patterns in the observable world, described compactly. But there's an immediate problem. My coin pocket is also a universal regularity. It happens to always be true. So why isn't it a law? This is called the problem of accidental regularities. And it's devastating for simple regularity theories. Laws and accidents can both be true everywhere and always. But they behave very differently when we start asking hypothetical questions. The law about electrons supports what philosophers call counterfactuals. If something were an electron, it would have that charge. Even if no electrons had ever existed, that would still be true. But my pocket doesn't support counterfactuals. If you put a penny in my pocket, it wouldn't suddenly become silver. The generalization is true, but it's just lucky. It doesn't tell us what would happen under new conditions. Laws explain and predict. Accidents just describe. In the 1970s and 80s, David Armstrong, Fred Dretske, and Michael Tooley proposed a bold alternative. The necessitation view. Laws, they said, are not patterns in particular facts. Laws are relations between universals. The abstract properties that particular things instantiate. They wrote this as N of F and G. The universal property F necessitates the universal property G. This is a higher-order fact about universals themselves. And it explains why laws support counterfactuals. The necessitation relation holds independently of any particular instances. If F necessarily produces G, then anything that is F, in any possible world, will be G. That's not an accident. It's metaphysical necessity. But the necessitation view faces a powerful objection from van Fraassen. Sure, he says, you can posit a special relation N between universals. But what does that actually explain? You've just given the mystery a name. What is this necessitation relation? We can observe particular electrons having particular charges. We cannot observe a universal called charge, bearing some abstract relation to another universal, called electromagnetic force. And here's the deeper problem. Even if N of F and G holds, why does that force individual F things to be G? Armstrong seems to just assume the connection, which is precisely what needed explaining. We've solved one problem by creating another. The accidentality problem is gone. But we've replaced it with an ontological and epistemological puzzle. Dispositionalism offers a third path, associated with philosophers like Brian Bird and Sidney Shoemaker. The core idea: fundamental properties have essential dispositions built into them. Charge doesn't just happen to attract opposite charges. Attraction is part of what charge is. On this view, laws are not external constraints imposed on properties. Laws flow from the inner natures of the properties themselves. This is elegant. It doesn't require mysterious necessitation relations between abstract universals. It just says that properties are inherently powerful. They have a nature that determines how they act. But critics push back. Couldn't charge have had different dispositions in a different possible world? Are the laws truly necessary? Or just deeply contingent? David Lewis, building on Frank Ramsey, proposed a very different kind of answer. The best system account. Imagine writing down every particular fact that occurs in the entire history of the universe. Now ask, what is the simplest, most powerful deductive theory that entails all of those facts? The axioms of that best theory are the laws of nature. This account has real virtues. It's empiricist-friendly, no mysterious universals required, and it explains why laws support counterfactuals. The best system's axioms are robust enough to hold across hypothetical variations. But there's a worry. The best system depends on what we find simple and strong. Does that make laws partly mind-dependent? And what if there are multiple equally good systems with different axioms? Whatever view you hold, every theory must grapple with counterfactual support. Laws don't just tell us what happens. They tell us what would happen under conditions that have never occurred and perhaps never will. The philosopher Marc Lange argues that counterfactual stability is actually the defining mark of lawhood. Laws are precisely those truths that would still hold even if you hypothetically intervened on the initial conditions. This gives us a test. A true generalization is a law if and only if it would remain true under any hypothetical supposition that's compatible with the laws themselves. Laws form a stable, self-reinforcing web. Accidents are fragile. They could easily have been otherwise. The debate gets even messier when we ask, are there laws in biology, economics, and social science? Physics gives us clean, universal, mathematically precise laws. Force equals mass times acceleration. Energy equals mass times the speed of light squared. Exceptionless. Everywhere. But what about natural selection? Biologists call it a law, but it has exceptions. It requires specifying the right conditions. And it holds only, for the most part. What about supply and demand? Economists treat it as law-like, but it holds only ceteris paribus. All else being equal. And all else is almost never actually equal. Jerry Fodor famously defended ceteris paribus laws as genuine laws with more restricted domains. But many philosophers worry, if a law has enough exceptions, does it deserve the name? We end, as so often in philosophy, with a question that opens onto the deepest issues. The four views we've explored give very different answers to whether laws are discovered or constructed. Regularity theorists say laws are just out there in nature. We discover patterns. Necessitation theorists say we discover objective relations between universals. Dispositionalists say we discover essential natures baked into properties. But the best system account suggests something more unsettling. Laws are partly our construction. They depend on what we find simple, what we find powerful, what we take to be a good theory. Maybe the universe itself doesn't come pre-labeled with laws. Maybe lawhood is our way of carving nature. A feature of our best maps, not of the territory itself. And if that's right, what does it mean to say we're discovering the laws of nature?